Power factor in modern systems. Welcome. Today we are diving into the heartbeat of industrial electrical efficiency. We are going to look at power factor, specifically how it impacts motors, industrial facilities, and the economics of your energy consumption. By the end of this session, you'll understand why this metric is crucial for modern systems. The physics of power. To truly understand efficiency, we first need to revisit the physics of power. In alternating current systems, the energy flowing through your conductors isn't always doing the work you think it is. Let's break down the difference between active and reactive energy. The dual faces of power. Think of electrical power as having two distinct faces. On the left, we have active power, measured in kilowatts. This is the real muscle, the energy that actually turns your motor shafts and lights your facility. On the right, we have reactive power, or kVAR. While it doesn't do useful work, it is absolutely essential. It creates the magnetic fields that allow motors and transformers to function. You need both, but you only want to pay for the first. Defining power factor. This brings us to the core metric, power factor. Simply put, it is the ratio of working power to the total apparent power flowing through your system. The ideal score is 1.0, or unity, which means zero wasted energy. However, in most uncorrected industrial sites, this number drifts down between 0.75 and 0.95, indicating a significant leak in efficiency. The inductive load challenge. So, what drags this number down? The challenge lies in our heavy reliance on inductive loads. Modern industry runs on AC induction motors, transformers, and welders. These devices act like sponges for reactive power, drawing massive current just to magnetize their coils. This inherent demand causes a lag in the system, dropping efficiency across your entire network. The cost of low efficiency. Why does this matter? Because low efficiency has real-world consequences. First, there are energy losses. Drawing excess current generates heat, which damages insulation. Second, there are direct financial penalties. Utilities often surcharge you for stressing their grid. And third, you are wasting capacity, filling up your transformers with useless, reactive power instead of leaving room for expansion. The solution. We have identified the problem. Now, let's look at the solution. How do we mitigate this inductive lag and reclaim our system's capacity? The answer lies in power factor correction. Capacitor banks. The industry standard solution is the installation of capacitor banks. These units effectively act as local generators for reactive power. By supplying the necessary magnetizing current right next to the load, they cancel out the inductive draw from the motors. This relieves the upstream grid and brings your power factor back up towards unity. Demand comparison. Let's look at the hard data. This chart represents a fixed 100 kilowatt load. At a perfect power factor of 1.0, you only need 100 kVA of capacity. But watch what happens as efficiency drops. At a power factor of 0.7, that same work requires 142 kVA of capacity. That is over 40% more strain on your infrastructure to achieve the exact same output. That is the hidden cost of a low power factor. Modern correction systems. Correction technology has evolved. We aren't just using static banks anymore. We now utilize intelligent APF relays that monitor the load in real time, automatically switching capacitor steps on and off. We integrate centralized panels into main switchgear, and engineers use advanced monitoring to track harmonic distortion, ensuring the correction process doesn't destabilize the network. Key operational benefits. Implementing these systems delivers immediate ROI. You will see a reduction in utility bills by eliminating penalties. You effectively release system capacity, avoiding expensive hardware upgrades. You also reduce voltage drops and thermal stress, meaning your cables run cooler and your equipment lasts longer. An economic imperative. In conclusion, understanding and managing power factor is not just an engineering best practice, it is an economic imperative. Whether you are running a single factory floor or a massive grid, optimizing your power factor is key to operating an efficient, compliant, and future-ready system. Thank you.